Hi, my name is Allison Hess-Dunning, and I have been an investigator with the APT Center for about 10 years now. Prior to joining the APT Center, I received a BS in engineering physics from the University of Pittsburgh and an MS and PhD in electrical engineering from Case Western Reserve University. Outside of work, I enjoy various crafts, jigsaw puzzles, and I'm a pretty intense Cleveland baseball fan. My research focuses on developing next generation neural interfaces that can help restore function impaired by a neurological injury or disease. Toward this end, I seek to identify promising neural interface materials, then develop the requisite nano and microfabrication processes to integrate those materials into a system that will best perform and integrate within the body. One way to improve long-term functionality and biological acceptance of a neural implant is with localized drug delivery to control the tissue response to the implant. However, drug release is often a trade-off between release duration and the invasiveness of the implant. But in our current Stephen Garverick Innovation Incentive Program Award, I'm working with my co-investigators, Hoda Amani Hamadani and Jeff Capadona, and our team to develop a mechanically flexible neural implant with integrated multifunctional drug nanoreservoirs that enable months-long drug release without an increase in device invasiveness. We expect that our innovation will contribute to a substantial improvement in clinical safety and therefore promote translation of mechanically flexible intracortical brain-machine interfaces.